We're Group Big Smart.
We're Big Smart. Smart!
Woo! Yeah, I'm Robert.
I'm Tian.
I'm Lou.
And we're going to tell you all about our Uber Audio Mixer 9000X, our audio processing project for ENG6. Tian, you want to get us started off?
Yeah. My part is doing the input-output arguments. So over here is the load button. I can load sound file over here. And to press the play button, I can play the sound. Like that. Also, if I click the stop, the sound will stop. So here's the code. For the load button, it's let me find it. For the load button, this code to record is to recording the information of the audio file, and those functions to save the information to handles structure. And for here is the slider function. So I use the timer function to record the time. And over here we can set the new information to our slider, so make it move with the audio. Then let me show you some effects. Over here is speed up. And here is slow down. Here is echo. It takes time. So here is the codes. Fine. For the speed up and slow down function, I just change the frequency and multiply by certain number to change the speed. And echo, I use the filter function. So this code up here is aimed to update the information of player in timer function. So Bobby?
Yeah, I'll take away from right there. So the next thing we did was we did the reverse effect. So if you play this, it'll play it backwards. You can barely even tell that it was a block by James. The next thing that is relevant to show is this here plot. So using a pop-up window, we were able to change it to a spectrogram 2D map and back to amplitude versus time. Those are our two graphs that we wanted to share. So if you want to see the code for all of this, so start with the reverse button. The reverse button uses the internal flipbud function to flip the audio data upside down. That way it plays it backwards. The next thing is the graphing, the pop-up menu. Now the pop-up menu is a graph select button, is what we called it. And it uses, if the pop-up choice, so it uses a string compare. If the pop-up choice is a certain string, then it'll plot this amplitude versus time plot. But if it is a spectrogram 2D map, it'll plot the spectrogram. The next thing that is important to note would be the none button, which negates all the effects of the previous effects applied to the audio. So if you click on the none button after clicking on the sound effects, it just sounds normal. Luke, you want to take it away with the equalizer?
Yeah, okay. So the equalizer, you can see, well, we have the graph here obvious already. And then if you could change up, down a little bit, this kind of sound different. Let me just play around with it real quick. Okay. Okay. And then you want to pause it and change it up, change it a little bit more. Play around. Let's get it back here. So how we did that was, let's go down to the functions. So we first set up all the, where is it? Let me find it. One more moment. I'm gonna find it. Oh, it's here. Okay, so here are the functions we set for the sliders. But I start with
This is the function that applies the filter, gets the coefficients in there.
yeah, right. Then the important thing to know is the difference between the pass band and the stop band gotta be the difference between that gotta be from 0 to 1, and then the RP1, RP and RS number has to fit into those two, and then we basically divided the range of human ear can hear to from 2.5K to 20K into 8 different pieces, and then we have a high bound and a low bound for those. So that's why you can switch back here and it's able to function. And then we have the plot button, which the plot function up here, which plots the graph. That's pretty much about it.
Well, that's awesome. So we hope that this here project has inspired you to create your own. And it was a wonderful experience to create, full of its trials and tribulations, but rewarding nonetheless. I'm Bobby.
I'm Tian.
Lou!
And thank you so much for watching.
Yeah, thank you.
Thank you!